Hello all of you. This is continuation from the first part of the practice questions of the mathematics of the grade 7. Here I go from number 24. So here says what? Convert 3.4 bar into the fraction. So here repeated decimal is given and that we have to convert here into the fraction. Is it? So how we start here? This 3.4 bar which we are given, that we suppose first x. Is it? And so here 4 bar is what? It's 4 repeated. Is it? So it's 3.44 continually it goes. Is it? And that we suppose here x, right? And after supposing this is x, is it? So what we do here is this decimal we will shift one place to the right side from left, right? So for that, first we suppose this is first equation, right? So 3.4 bar we are supposing as first equation, and it's what? 3.444 continually 4 over there. And now we have to shift decimal one place from left to right side, and for that we have to multiply by 10, right? So multiplying both sides by 10, okay, so 10 into 3.444 is it equal to 10x, is it? So that way we get there what? 34 point, is it? So by 10 we multiply, so decimal one place is shift from left to right side, so point will be here. So 34.44, and as many fours you can keep there, is it? So that equal to 10x, and this we denote as the equation number 2. And now the first equation, is it? So this is not above one first, right? That we suppose, and this is the equation first, right? So first equation we get subtracted from the second equation. So we say here subtracting equation 1 from equation 2, is it? So in equation 2 on the left side we do have 34.444 continually, and from this we are subtracting left side of first, that is 3.444 continually, and on the right side second equation there is 10x, and in the first there is x, is it? So this way we get subtracted. And when we subtract, so to make it more clear, is it, I write this in rough. So 34.444 that we do have, is it? And 3 point decimal we have to align here to subtract, so 0.444, that's, is it? So these two numbers we are making subtract, right? So here these 444, these are same, so they will get cancelled. So which we get subtracted as 34 and 3, is it? So 34 minus 3 we get there 31. So the thing is there, right? So we get there 31, and that equal to 9x, is it? So 31 divided by 9 equal to x we get, so done, is it? So therefore 3.4 bar equal to 31 divided by 9. So I hope I made it clear with this number 24. And now same way we go for 25 number. So for that I make clear this one. Okay, so for number 25, convert 6.23 bar. So here bar is above the 2 and 3 after decimal, so 2 3 is repeated there, is it? So 6.23 bar, that we suppose here x first, is it? And now thing is what? It's what? 6.23, 23 getting repeated, so 23 23, is it? 23, it's like that, right? So equal to x, right? And now this we suppose as equation first, and now we have to shift here decimal for 2 digit from left to right, so how I show here in rough, right? 6.2323, like that we do have, is it? So this decimal we have to shift from here to here, right? At this point we have to shift it, is it? So 2 digit you have to shift from left to right, is it? That is why you have to multiply by 100 to do that, right? So let's multiply this equation 1 on both sides by 100. So we say here multiplying both sides, multiplying both sides by 100, is it? So you get there 100 into 6.232323 continues equal to 100x, is it? And thing is what, when we multiply the number 6.2223 by 100, so decimal will shift for the 2 digit from left to right, so 6 to 3 we get, is it? And decimal 2323 like that, is it? So equal to 100x, and this we get suppose equation number 2. Another thing is what, the first equation we have to subtract it from the second equation. So you say here subtracting equation 1 from equation 2, is it? So 623.2323 dot 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 minus 6.232323, is it? And that equal to 100x minus x. So what you are going to get here, so let's see this in the rough side, alright? So from 6 to 3.23 continue of 23, we are subtracting 6.2323, okay? So this way we are subtracting. So here these two values are same, which are after decimal, is it? So they will get cancelled, over here, is it? And after cancelling, from 623 we get there 6 subtracted. So how much we're going to get there? So 13 minus 6 we do, is it? So 7 we get, and 1, 617, is it? So it's here 617. So 617 equal to 99x. So therefore we get there x equal to 617 divided by 99, is it? So it's improper, and if you want to convert it into the mixed fraction, we can convert it, is it? So therefore 6.23 bar is equal to 617 divided by 99 or 99, right? Okay, so 25 I made it clear, and now we go with the number 26. So let's make this 25 clear first. Okay, so we gone 24, 25, now we are on the 26, is it? So thing is what over here in 26, what's said here, how can you identify any given fraction as either terminating or non-terminating without performing the actual calculation, right? Okay. So thing is what over here, when will be any fraction terminating or non-terminating, that we have to know first, is it? So for that what we do here, the thing is what, if denominator consists product of the 2 and 5 or 2 alone or 5 alone or some powers of 2 and 5, like then this fraction they will be terminating decimal, is it? And if it's not being there, or if there is any other number than 2 or 5, is it, then such fractions will be non-terminating decimal. So I will let you understand through an example. Suppose there is 3 by 5, is it? So here 3 by 5 denominator is 5, so it's terminating decimal because here is 5. Or there is 7 by 2, is it? So their denominator is 2, is it? Denominator is 2, so it's also terminating decimal, is it? Or their powers alike, so their powers mean, suppose there is 3 divided by 5 square, I mean there is 3 by 25, so there if consisting powers of 5 square, 5 power 3, any, right? Or 2 square, 2 power 4, 2 power 5, any, is it? Or their product, is it? So if those values are in denominator, they will be the terminating decimal, so that you have to mention here. And if denominator is consisting factors other than power of 2 and 5, or factors of 2 are 2 and 5, or 2 or 5, is it? So other values than 2 and 5, if they consistent in the denominator, then such fractions will be non-terminating decimal, is it? So here these examples I gave for the terminating, is it? These are for terminating decimals. And non-terminating, how can you identify? Non-terminating, so in denominator there consists other factors than 2 and 5, right? So just like suppose there 3 by 7, so here denominator you see 7, is it, which is not either of 2 or 5, so it's non-terminating decimal. Suppose there is 3 by 14, there is 2 also. In 14 there consisting factors 2 and 7, 2 consisted also there, but more than 2 there is 7 also, is it? Other than 2, if consists other than 2 or 5, if this consists over there, then those fractions will be non-terminating decimal. So there is this 3 by 14 where 7 is consisting in the denominator as a factor. 14 if you break, you can get 2 into 7, though 2 there is 7 also, is it? So it's non-terminating decimal. This also non-terminating decimal. So same like you can find these things and you can define similarly. Alright, so now I go with number 27. So what's said there in 27? Let's see. So in number 27, how can you justify 3 by 20 is terminating decimal? Is it? So same thing what we have discussed in number 27. 26 is there. Alright, so 3 by 20. Alright, so if you see 3 divided by 20, let's see by breaking 20, so it's 2 into 2 into 5, is it? 4 5 is 20 and 4 is 2 into 2. So you see here only 2 and 5, is it? So other factors than 2 and 5 you don't see in denominator. That is why it is terminating decimal. So if you divide actual with the actual division or long division, 3 by 20 will form their terminating decimal, is it? So this is terminating decimal since denominator consists only factors of 2 and 5, right? So it's of number 27. Now number 28, how can you justify 7 by 3 is not terminating decimal? So thing is very same. Here denominator you see 3, is it, which is the number other than 2 and 5. That is why 7 by 3 is non-terminating decimal. So that way the same thing you have to explain there if it is asked such way. Alright, now I made it clear up to 28. Now I go for the next question from 29 onwards. So I make it clear first. Okay, so from number 29, from 29 up to 33 I'm showing here now. Okay, let's hear this. See, so in number 29 what is said here? What is the ratio of 50 minutes and 5 hours? We're asked to find a ratio of 50 minutes and 5 hours. So these both are time, but units are different. So first we have to convert both into the same unit, either both into the minutes or either both into the hours. So easy will be converting hour into the minute. We already know that 1 hour is 60 minutes, so let's convert 5 hours into minutes first. Alright, so first we say here for this number 29, how many minutes will be for 5 hours? So 5 hours, each hour consists 60 minutes, so 5 hours will become a 5 into 60 minutes, so you get there 300 minutes. So then you can find ratio of 50 minutes and 5 hours. So we have found here 50 minutes same, is it? And we have found what? This down 5 hours is 300 minutes. So we have converted both times into the same unit, minutes. So now we can find. So 50 divided by 300. So by 10 we got 10 5s are 50, 10 30s are, and by 5 we can cancel. It's 30 for 6 times. 5 1 is 5, 5 6 are 30. So it gets there 1:6. So therefore required ratio is 1:6. So step number 29. Now I go with number 30, and I make this component clear first. Okay, so number 30 now. So in number 30, what's said here? What is the compound ratio of 3:5 and 2:7? We are asked to find the ratio of here 3:5 and 2:7. Is it? So compound ratio, when we find those two ratios, we have to multiply. For given any two ratios, if we are about to find their compound ratio, those two ratios we have to multiply. So compound ratio of 3:5 and 2:7 equal to 3:5, that's 3 by 5, and into 2:7 means 2 by 7. So you can cancel here any numbers, is it? So 3 into 2 6, 5 7s are 35. So 6:35 is the required result for the compound ratio of those two given ratios. Now I go with number 31, and okay, let's clear it first. So for 31, what's the idea? See, which ratio is greater, 2:5 or 3:4? Is it? So we are given here two ratios, where we do have here denominators 5 and the 4. Is it? So to identify which is greater or which is lesser, is it, we have to convert their both denominators in the same value. That first thing what we have to do, is it? So for that, denominators we see, and their LCM we identify, and we convert both the ratios into the values with the same denominator into the LCM of those values of denominators. Alright. So first we have to find here LCM of denominators. So here LCM of denominators 5 and 4. That equal to 5 into 4. No common values are sharing by 5 and 4, so directly their product will be the LCM, so that is 20. Is it? So what you have to do here, in both ratios we have to make denominators 20. So first is 2:5, so denominator you see here 5, so let's make it convert it into 20, and for that we have to multiply by 4. Is it? So for both values of denominator and numerator of 2:5, we multiply by 4, and that way we get there 8:20. Is it? So denominator we got the 20, and our second ratio is there 3:4. Is it? And here you see denominator 4. Is it? And now to convert this denominator 4 into 20, we have to multiply by 5. Is it? So let's multiply both values of 3:4 by 5. So 3 into 5 is to 4 into 5. So that way if we do, we get there 15:20. And now we can compare. Is it? So here we got both denominators same, and now numerators, let's see, we do have 8 and 15. So here 15 is greater than 8. Is it? So the thing is what? Here 15 is greater than 8. So it means what? 15:20 is greater than 8:20, and 15:20 is actually 3:4. Therefore 3:4 is greater than 8:20. Actually that is 2:5. So done. So it's off number 31, and I go with number 32. So make first this clear. Okay, so in number 32, we are said to arrange the given ratios in ascending order. So three ratios we are given here: 2:3, 4:5, and 6:7, and we are asked to arrange them in ascending order. So very same as 31 we did, we have to do the thing here. So denominators we see, right? 3 you see, 5 and 7. So the LCM we have to identify first, right? To convert all the ratios with the same denominator, we take what? LCM of denominators. So here we take LCM of denominators. So LCM of denominators, 3, 5 and 7, is it? And 3, 5, 7, they are not sharing any common factors, so directly their product will be the LCM of the denominators. So how much you're going to get? 5, 3, 15, 15 into 7, is it? 7, 5, 35, 7 on 7, and 3, 10. So 105 is the LCM of the denominators, is it? So 105 we have to make in all three ratios in their denominators. So first we go with 2 is to 3, is it? And for 2 is to 3, is it? So here we see denominator 3, is it? And now by what we have to multiply, we have to think. So except of 3 there are 5 and 7, is it? So by the product of 5 and 7 we should multiply to make 105 in denominator. So 2 into 7 into 5, that is 35. By 35 we multiply, and into 3, for 3 also we multiply by 35. So 2 into 35 we get 70, and 3 into 35 obviously it's 105. So first ratio 2 is to 3, we turn with the denominator 105, which is LCM of those denominators. Now we go for the second ratio. So second ratio we do have here 4 is to 5, and now except 5 in the 105 there are 3 and 7, so their product is 21, is it? So by 21 we have to multiply here. So by 4 we multiply here 21, is it? 4 we multiply here 21, and 5 also we get multiplied by 21. So 4 into 21, 82 we get, and 5 into 21 is obviously 105, is it? So second ratio also we turn into the same denominator 105. Now turn for the third ratio. So third ratio we do have here 6 is to 7. So except of 7 there are 3 and 5, is it? Except of 7 there are 3 and 5 as a product in 105. So 3 into 5, that is 15. So by 15 we have to multiply into the both of these denominators of 6 is to 7, so that we'll get 105 in the denominator. So let's do the thing. So 6 into 15 we do, 7 into 15 we do, is it? So 6 into 15 we do, how much you get there? That's 90, is it? And 7 into 15, that is 105. So this way we have turned all three denominators now same, is it? And now numerators we compare 70, 82 and 90, is it? And thing is what, we have to arrange them into the ascending order, is it? So when arranging in ascending order, small to highest we have to keep, is it? So small to highest, 70 compared to 70 the greater is 82, then compared to 82 greater is 90, is it? So this way numerator when we compare we have arranged like this, is it? And now let's keep here their denominators 105, here 105, and here also 105, is it? So this way we converted or we compare by keeping given ratios into the ascending order, and their actual values are 70 by 105 is 2 is to 3, is it? And 82 by 105 is 4 is to 5, and 90 by 105 is 6 is to 7, is it? So these arranged serial, these are already arranged in serially, right? So the answer we got, is it? Now I go with the number 33. So I make this first clear. Okay, so in 33 what is it here? See, which new ratio is formed if the denominator is increased by 2 and numerator is decreased by 1 in the ratio of 7 is to 20. So some changes are made in the original ratio, is it? So we do have here original ratio 7 is to 20. Let's write that first. Original ratio is equal to here 7 is to 20, is it? And now denominator is increased by 2 and numerator is decreased by 1. So let's do for first numerator. So when numerator is decreased by 1, So new numerator, or change numerator you can say. So numerator was 7 in original ratio and 1 is decreased, so it is 6, is it? So new numerator is 6, and in the denominator there is 2 increase. So when denominator is increased, right? When denominator is increased by 2, so new denominator. So new denominator equal to, so denominator originally there is 20 and it's increased by 2, so we get there 22, is it? So we came to get here new numerator 6 and new denominator 22, so we can get their new ratio. So new ratio equal to 6 is to 22, and we can simplify it because both are even and you can cancel them by 2. So 2 3s are 6, 2 11s are 22. So new ratio will become here 3 is to 11. So up to number 33 I made it clear. Now I go with 34 onwards, right? So I make this clear first. Okay, now I go from 34 onward. So 34 to 38 I take here now. Okay, so first I go with 34 number. So what's here? See, a class of grade 7 consists 20 boys and 80 girls. So originally there are 20 boys and 18 girls. And said here what? If new boys, 2 new boys and 3 new girls were added. Is it? So what will be the new ratio of boys and girls? So it's very same as the 33 number we did. So original number of boys and girls, they are already given here. 20 boys and 18 girls are there. And here said what? 2 new boys are added. So number of the boys after change, you can say number of boys after 2 new boys added. So how much you're going to get there? So originally there were 20 boys, 2 new boys added, so 22 boys will become, right? And girls, so girls here what happened? 3 new girls were added. So number of girls after 2 new girls are, sorry, 3 new girls are added. After 3 new girls are added. So here originally there were 18 girls and 3 new girls added, so 21 girls became here after change. So new ratio, so new boys and new ratio, there are 22 and 21, so we can find their ratio, is it? Then new ratio of boys and girls, you see, then new ratio of boys and girls equal to 22 is to 21, and you can cancel them. So that's it, is it? Okay, so it's of number 34. Now I go with 35, right? So I make clear this first. So for 35, what's it? You see, by which the smallest value 28 should be multiplied to make it perfect square? Is it? You said what? By which smallest value 28 should be multiplied to make it perfect square? So for that we have to break it 28 first. Is it? So 2 1s are 2, 2 4s are 8. Is it? And 2 7s are 14. So here 28 is consisting factors 2, 2 and 7. So here 2 is in pair. Is it? 2 into 2 will give the perfect square. Where square is not happening, that is 7 only, is it? So if we multiply it by 7, is it, again it will be perfect square, is it? So thing is very same. So you have to say here to make 28 perfect square, by 7 it should be multiplied, or by smallest number 7 it should be multiplied to make it perfect square. So you should give same answer. Now 36 number. So it said here, what is HCF of 18 and 27? Very easy numbers here, is it? So to get the answer done, what you have to do here, so let's make these two factorize first, is it? And let's get the LCM done. Let's get the HCF found, right? So 2 9s 18, 3 3s 9. So 18 is over here, 2 into 3 into 3, is it? And now for 27, do the same thing. By 3 it get cut. 3 9s 27, 3 3s 9, is it? So here 27 is product of 3 into 3 into 3. And now you see here common terms or common values. So 3 is here common, is it? And next there is another 3 also common, is it? So their product we take, which will be the HCF, is it? So here is say HCF equal to product of the common factors, product of common factors. So common factors are 3 and 3, so their product is 9. So therefore HCF is equal to 9. So done, is it? So it's up 36. Now I go with number 37. So this one I make clear first. Okay, so in 37 we're asked to find the LCM, is it? So to find the LCM there are two ways, right? So I'll go with the first rule, CF into RF, common factor into remaining factor. So individually I'll break it first. 2 6 is 12, 2 3 is 6. So here 12 you can write as a product of 2 into 2 into 3. Now I go with 15. So 15 is here 3 into 5. So 15 I write 3 into 5. And after that 27 is there, is it? So 3 9s are 27 and 3 3s are 9. So here 27 is product of 3 into 3 into 3, is it? And now to find LCM, what we have to do here is we have to make product of common factor and the remaining factor. And for the LCM to be the common factor in any two given numbers, if there is being common, then that can be also considered as common factor. It's not needed to be common all the numbers which are given, 2 number, 3 number, 4 number, is it? And all the numbers need not to be common over there, is it? At least in two numbers, if there is being common, then that can be taken as a common factor. Unlike to the HCF, when we find HCF of the three numbers, is it? So common factor must be from all three numbers, is it? But for not the LCM, for LCM, if there is common being at least in the two number, that can be taken as the common factor, right? But here you see this 3 is being common in all three numbers, is it? So this is the common factor. And in other number you see there is no other numbers as a common, so other all will be considered as remaining factors. So here we take common factor is 3, is it? This is the common factor only 3, right? And now we'll be serially taking remaining factors from the all the numbers, right? So from 12 we take remaining 2 and 2, and it's from first number 12 remaining, and from 15 there remaining 5, is it? Is from the second number 15, and then next from the 27, so remainings are 3 and 3, so their product we keep, is it? So what will be the product of these values you can find, is it? That will be the value of the LCM. So you do it, you can do it yourself, right? And I go with number 38, right? So I make it clear. So here in number 38, so it said, see, what is the highest number of students whom 40 books and 60 note copies can be distributed equally, is it? So that's the value of the HCF, is it? So which will be the highest common factor of these two numbers, 40 books and 60 note copies? That will be the highest number of students whom we can distribute those books and note copies equally, like, okay, so the number is HCF, the highest number of students, right? Highest number of students whom 40 books and 60 copies can be distributed equally, is HCF of 40 and 60, or of the HCF of the number of 40 books and number of 60 copies, is it? So let's find their HCF, is it? So 40, if you break, you can get there to 20, to 10, to 5, is it? So 40 you can write down as product of 2 into 2 into 2 into 5. And now 60, if you do, when you break, 2 into 30, 2 into 15, and 3 into 5. So let's break 60 and write over here 2 into 2 into 3 into 5. Right, so we can identify here some common values. So 2 you see common, another 2 you see common, and another 5 you see common, is it? So here HCF is product of the common factors, is it? So these are 2, 2, and 5. So 5 4s 20, is it? So here 20 is the LCF of the numbers of these books and copies. So you can say what? So highest number of students is 20, whom we can divide these 40 books and 60 copies equally. So it's done with number 38. Now I go with the numbers from 39 onward. Okay, so let's make it clear first. It is getting reached. Okay, fine. Okay, so up to 30 number 38 number I did. Now 39 and 40 I go first, right? Okay, let's say here, see, there are 3 bells kept in 3 blocks of school ring at different intervals of 40 minutes, 45 minutes, and 60 minutes respectively. So they're given what? 3 bells are kept in 3 different blocks of a school, and they ring at intervals of 40 minutes, 45 minutes, and 60 minutes respectively, is it? And thing is what over here, they rung together at 8 a.m. morning, is it? They first rung together at 8 a.m. morning. Now question is what? Find out what time they will ring together for the next, is it? So next time we have to identify when they will ring together again after 8 a.m. So that time is the time of interval, which will be the LCM of these 3 times where they ring at their intervals. Right? So first we identify here LCM of these timings. Right? So let's find your LCM of 40. Finding, you say here finding LCM of 40 minute, 45 minute, and 60 minute. Is it? So I go directly over here, is it? So 40, 45, and 60, is it? Now they are divisible by 5. 5 8s are 40, 5 9s are 45, and 5 2s are 60. Okay, and after that, now next they go divisible by 2 and 3. Okay, let's go with 2 first. 2 4s are 8, and 1 go, so keep same. 2 6 are 12. And now again we can go again with 2. 2 2s are 4, 9 same. 2 3s are 6. And then next we can go with 3 by 3. 2 we keep same. 3 3s are 9. 3 1s are 3. So the 2 and 3 both are the prime factors. So is it? So now we find the LCM as product of all these values, right? These all values we get their product, and that with the LCM. So 5 into 2 into 2 into 3 into 2 into 3. is it? So here 5 and 2 you get there 10, 10 2 you get there 20, 23 you get there 60, is it? And last 2 into 3 you get there 6, is it? So it is 360. So LCM is over here, therefore LCM is equal to 360 minutes, and 360 minutes is mean it's how many hours. Alright, so let's identify. Okay, let's once make check again if any mistake is there or not. 40, 45 and 60, is it? So 5 is a 40, 5 9 45, 5 12 60, 2 4 8, 2 6 12, 2 2 4, 2 3 6, and 3 3 9, 3 1, is it? So 5 2 2, is it? 3 2 3, 5 2 10, 10 2 10 to 20, 23 60, is it? And 2 3 6, 16 6 3 6, that's right, is it? So LCM we got there 360 minutes. So 360 minutes, it's how many hours, is it? So we divide by 60, is it? Then we get their hours. So it is 6 hours. So next ringing the bell together, is it? That's after the 6 hours, is it? Each of these 3 bells ring at intervals of the 40 minute, 45 minutes, 60 minute every time, is it? But at every time they will not ring together, is it? In different intervals they are ringing, but the thing when they all 3 will ring together is after the 6 hours. And at first they rung together at 8 a.m. Now after 6 hours of that time they will ring together. So after 6 hours mean how many? Let's identify. So next together ringing time, is it? Next together ringing time is 8 a.m. 8 a.m. plus 6 hours. So 6 hours you have to break such a way that you can count after 12 also, is it? So 6 you break by so 8. In 8 you add 4 hours, is it? You get the 12, and then next 2 hours. So next 2 hours mean that is 2 p.m., is it? So in next time 2 p.m. at that time they'll be ringing together again, is it? So I made it clear with number 39, and I'll go with number 40. So let's make it clear first. Okay, now in number 40, what is this? See, here are shown some leadless cube. So I missed to copy a diagram. Okay, so they're given what? Some leadless cube, is it? So how many faces are there in the leadless cube? So in each leadless cube, how many faces are there? You have to see, is it? So this here you see leadless cube, is it? So here it's visible 4 faces around, is it? And 1 face down at which it is standing, is it? So total there are 4 plus 1, 5 faces, is it? So total number of faces, faces of leadless cube. So for the leadless cube, 4 faces around of it and 1 face which is down, is it? On which this object or this cube is standing, right? So total there are 5 faces. And if it is without the lead, it's not without the, it's without lead. Now if its lead is its top also closed, or some like Rubik cube, is it? So they're all faces are there together, so there will be 6 faces, 4 faces around, is it? And top and bottom face, so total 6 faces. Or you see our room, is it? 4 walls you see, and you can see floor and the ceiling, so total 6 faces will be there in the cube or cuboid. But here leadless cube, is it? So here only 5 faces. So I made it clear with this number 40 also. Now on our 40 we go. On our 41 we go. So now we go with the 41. Okay, first 41 number I do here. So what's said here? See, it's a game board, is it? Where 6 and 36 are kept in vertical squares. So 6 here kept vertically above, and vertically below there is kept 36, which are HCF and LCM. So this 6 is the HCF and this 36 is the LCM, is it? And then so what? On horizontal squares there are the numbers from which that LCF and LCM are formed. So this 12 is the first number, is it? 12 is the first number, is it? And now this empty box, it should consist second number. Now we have to find here what should be the value of the in the empty box, or what is the second number. And now relation between the two numbers and their HCF and LCM we need to know, and that we'll be using to find the value of the second number. Right? So the thing is what first number, right? So product of the numbers and product of HCF and LCM, they will be equal. Right? So that we use here to identify the value of the second number. So first number into second number equal to HCF into LCM, is it? So first number we are already given 12. So 12 into second number. So 12 into second number equal to HCF we do have here 6, LCM we do have here 36. So or we say, so second number equal to 6 into 36, and 12 getting multiplied there, so it will go down for dividing, is it? So by 12 it can cut 36 for the 3 times, so 6 into 3 is there, and that is 18. Therefore here second number is equal to 18. So done. And now after doing the second number, now I go with the finding this second number of the question number 41. I go with the 42, is it? So for going with the 42, I make clear of this first. Okay, number 42 I'm going. So in 42 was said here, see, 42 and 43. Okay, so two number together I go 42 and the 43. Okay, so in number 42 said here, see, how many liters of water can this tank hold if 1 meter cube can hold 1000 liters of water, is it? So here one cuboidal tank, rectangular base tank is given, is it? And we have to identify how many liters can it hold with the fully occupied, right? When 1 meter cube can hold 1000 liter. So it's the general thing, 1 meter cube holds 1000 liter. It may not be given to you, we have to know it by yourself. Right? Now to find how many liters will be kept, can be kept in this cuboidal tank, we have to identify its volume first, is it? So here length, breadth and height all are given, is it? So here length is given 6 meter, breadth is given 5 meter, and height is given 4.5 meters. So we have to find the product first, is it? So here volume of the, with this 42 number, volume of tank we find first. Volume of cuboidal tank, you can say volume of cuboidal tank. So that's equal to product of length, breadth and the height. So length we are given here 6 meter, breadth we are given here 5 meter, and height we are given here 4.5 meter, is it? So 6 into 5 30, and 30 into 4.5, is it? So 30 into 4.5 if you do, is it? So how much you're going to get there? 30 into 4, is it? 120 we get, and 30 half is 15, is it? So we can get there 135 meter cube. So volume of the cuboidal tank is 135 meter cube, or you may multiply 30 and 4 into 5 directly also, so you can find, you will be finding here 135. And I did what is, I splitted this 4.5, is it? 4.5 is 4.5, is it? So 4 into 30 120, and half of the 30 is 15, so 120 plus 15, I got there 135 meter cube. Alright, so here 135 meter cube is the capacity of the tank. Now we can identify how many liters it can hold, right? So here you say 1 meter cube holds 1000 liter, right? 1000 liters of water. then 135 meter cube. So it holds 1000 into 135. So 135 into 1000 liters of water, is it? So that's what over here, 135 3 times 0. So it's 135,000 liters, or 135,000 liters of water it can be kept in the tank, right? So it was of the 42 number, and now I go with the number 43. So I make clear of this first, is it? So let's make it clear. Okay, so to make clear of this number 43, is it? Let's say here, let's say what should be the height of the given cuboid to have the volume of 800 meter cube. So it said here volume of the tank, or volume of the cuboidal tank is over here, or this cuboid is over here with the volume of 800 meter cube, and their length and breadth are given already, right? So length given 10 meter and breadth given 8 meter. We have to find out the height. So the same concept we'll use here. So volume equal to volume of cuboid. So it's given here 800 meter cube, and its product of length, breadth and height is equal to 800, and their length and breadth they are given 10 and 8. So into height equal to 800, is it? So height will become here 800 divided by 10 into 8, is it? 10 and 8 both will come down for dividing, or you can use here. So by 10 this will cut, and 800 will cut for 80 times, is it? So 10 into 80 is 800, is it? And by 8 you can cut 80 for 10 times. So height is 10 meter. Therefore you can say here height of the cuboid is 10 meter, is it? So I made it clear with this number 43. Now next we go for 44. So I made this first clear. Okay. Now 44. Done. Now with 45 and the 45, 46 onward, alright. So okay, so from 45 to 50 I'm taking. Okay, so let's say it here in number 45. Let's see. So here it says what? Write properties of vertically opposite angles. Alright, so what are the vertical opposite angles? Alright, those things we are asked here, is it? So vertical opposite angles are those which are made when two lines intersect and will be forming an opposite side. Right, so just like here in the down figure, is it? Here two lines you see intersecting, is it? And here vertically opposite they are made with the pair of this C with X, first pair, is it? And second A with B, is it? So that thing we have to write here. So the very first property is these angles or vertical angles will form when two lines intersect in opposite direction, is it? Or in opposite side. Angle form in opposite side when two lines intersect, is it? And now number 46, right? Identify adjacent, supplementary and vertically opposite angles of X in the given diagram. So thing is what over here, with X, which is the vertical opposite, and which are the supplementary angles or adjacent supplementary angles we have to see. So with X here, C is vertical opposite, is it? So we say here with X, vertical opposite angle is C. Vertically opposite angle is C, is it? And with XA, which are adjacent or which are joined, they are A and B, is it? A and B, they are adjacent to X and A, and they are supplementary as well, is it? So with X, adjacent supplementary angles, adjacent supplementary angles are A and B. Is it? So it's of the number 46, and I go with number 47. So let me clear this. Okay, so in 47 what's said, you see. So what is the complementary angle of 50 degrees? So complementary angles are those whose sum is 90 degrees. So to find complementary angle of any given angle, you have to subtract that angle from the 90 degree. Is it? So complementary angle of 50 is 90 minus 50. Is it? So you say here complementary angle of 50 degree is equal to 90 degree minus 90 minus 50 degree, so that we get there 40 degree. And in number 48 we are asked here, what is the supplementary angle of 100 degree? Is it? So supplementary angles are those whose sum is 180 degree. So to identify supplementary angle of any given angle, you have to subtract that angle from the 180 degree. So you say here supplementary angle of 100 degree, so that equal to 180 degree minus 100 degree, so that you get there 80 degree. Is it? So 48. And now 49. So it is asked here, see. So to make it, I'll make this clear first. So for 49, what is the supplementary angle of the sum of angles of 30 and 40? So you ask supplementary angle of what? Sum of the angles of 30 and 40. So first you have to identify here sum of angles 30 and 40 that given. Is it? Sum of angles 30 degree and 40 degree, and that's here 30 degree plus 40 degree, that is 70 degree. And now we are asked to identify supplementary angle of this angle. Is it? So then supplementary angle of 70 degree. So to find that, you have to subtract the 70 degree from 180 degree, so that you get the 110 degree. And so 49 is done. Now last number 50. So what's said here? If 3x and 120 degree, these are supplementary angles, what is value of x? Is it? So it either may be vertical opposite, it may be given as complementary angles. Here given what? These two given angles, 3x and 120, these are the supplementary angles. Then what will be the value of x, we are asked. Is it? So here, as these are supplementary, okay, I'll make clear this first. Okay, so 3x and 120, they are given supplementary, so it's obvious that their sum is 180 degree. Is it? And now to get the value of x solved, this 120 we need to send on the another side, right side. So sign will get changed, minus 120 will become, and 180 minus 120 we get this 60 degree. Is it? And now this 3 is getting multiplied with x, so it will go down for dividing. Is it? So 60 by 3, so when we cancel, so we get there 20 times, so value of x we get there 20 degree. Is it? So I guess you understood up to this 50 number from beginning. Is it? Thank you for watching everyone.